Alright, welcome to day 2 of graphing linear inequalities. Today we're going to focus on word problems since we practiced yesterday, which is graphing the linear inequalities. Today we're going to focus more on the word problems. So in question 1, a developer plans to build a housing for at least, there's our inequality symbol right there, 50 families. He wants to build some single family homes. There's our first variable. And some 4-family homes. There's our second variable. We need to write an inequality to model this situation. So if he needs at least 50 families, that means he can have 50, but he can also have more than 50. So our inequality symbol is going to be greater than or equal to 50. He wants to build some single-family homes, that's our X. And he wants to build some 4-family homes, that's our Y. So our inequality symbol is X, or our inequality is X plus Y is greater than or equal to 50. So when we go to graph this inequality symbol means that because it's greater than or equal to, it's going to be a solid line. And since it's greater than or equal to, we're going to be shading above the solid line. So you have two choices here. You can graph using X to the Y-intercept, or we can just convert this to a Y equals equation, which is fairly simple. Just subtract X from each side, and we get Y is greater than or equal to 50 minus X. So this gives us a slope of -1 and a Y-intercept of 50. So we're going to draw a graph to display the possible pairs of numbers of single-family houses and apartments the developer plans to build. So I'm going to graph using the slope and the y-intercept. The y-intercept is 50, which is right here, and the slope is a -1. So it's just down 1 and to the left, down 1 to the right. So we're just going to graph it just like that. But I forgot to do one thing. I forgot to label my axes, so I'll go back and do that in just a second. And since it's greater than or equal to, we are connecting this with a solid line. Hopefully your line is straighter than mine. So what I forgot to do was label my axes. So my x-axis we said was defined as the single-family homes, and I'm counting by 5s, but I'm going to skip count, so every other one is 10, 20, 30, 40, and then 50, and I'm going to do the same thing on the y-axis as well, 10, 20, 30, 40, and 50, and this is the number of apartments. Okay, so we had to draw a graph to display the possible pairs, and we did that. We didn't shade, however, and since this is greater than or equal to, we are going to be shading everything that is above that boundary line. So that is everything over here. So all of my possible combinations of single-family and apartment buildings are in that blue shaded area. So just as an example, I could pick, the builder or she could build 30 single-family homes and 40 apartments, and that would give him enough room for at least 50, which is good because then 30 plus 40 would give us 70, so that works. This could be another possible ordered pair, 40 single-family homes and 30 apartments. We could have 10 single-family homes and 45 apartments. All of those ordered pairs would work. Okay, for our second problem, math club members are selling games and puzzles. They make a profit of $10 on a game and $8 on a puzzle. They would like to make at least $200. There's our inequality right there. At least means they want to make at least $200. They can make more than that, but they don't want to make less than that. So at least means greater than or equal to 200. So we need to define our variables. They make a $10 profit on a game, an $8 profit on a puzzle. So we're going to let X equal the number of games and y equal the number of puzzles. So we're going to write an equality to model this situation. Each game they get $10 on, each puzzle they make a profit of $8, and they want to make at least $200. So, okay, what are some possibilities for the number of games and puzzles that the math club can sell to reach its goal? So let's assume that they don't sell any games at all. To make a maximum profit of at least $200, they would have to sell 25 puzzles. That's one combination. Well, let's say they didn't sell any puzzles. How many games would they have to sell to make at least $200? They would have to sell at least 20 games. So I'm just picking numbers. I could have 4 games and 20 puzzles. That would work. It would give, these numbers will give me exactly $200. 8 games and 15 puzzles, 12 games and 10 puzzles, 16 games and 5 puzzles, and like we said, 20 games and 0 puzzles. So here's our inequality. We want to draw a graph of all the number of games and number of puzzle pairs that meet this goal. So I need to label my axes. We said that x was the number of games, and we said that y was the number of puzzles. Okay, now I need to label my, put the scale on my x and y axis, and I'm going to skip count by 5s. So this is going to be 5, 10, 15, 20, and 25. Same thing on the y-axis, 5, 10, 15, 20, and 25. So I'm going to graph using the x and the y intercepts, and my x-intercept when y is equal to 0, so if I didn't sell any puzzles, I would have to sell 20 games. That's my x-intercept right there. My y-intercept is when x is equal to 0, so if I didn't sell any games, I would have to sell, or the math department would have to sell 25 puzzles. So now I have to look at my boundary line. So let's go back to our inequality. It's a greater than or equal to, so that means it's going to be solid, and I'm going to shade above my boundary line. So I'm going to make a solid line connecting my x and my y intercepts, and everything that is going to be shaded above the boundary line. Because I can make $200, I can make $210, but I don't want to make anything less than $200. So any of the coordinates or the ordered pairs inside this boundary line will work for my inequality. So we're going to graph, or actually I'm going to just label a couple of those ordered pairs. So we already said that 0 puzzles and 20 games would work. That's that point right here. We said that 0 games and 25 puzzles will work. If I have 4 games and 20 puzzles, which is, or I could have 4 games and 25 puzzles, which is somewhere up in here. Let me get my highlighter. But any of these things will work. 10 games and 20 puzzles will work. 15 games and 15 puzzles. I could have 20 games and 5 puzzles. I could have 5 games. Oh, I did that one already. I could have 10 games and 15 puzzles. Any of these sets of ordered pairs will work, and they'll work in the inequality because I want to make at least $200. Okay, let's go back to that. Okay, once again it's your turn. Multiple choice question 1. Which graph matches the inequality? Y is greater than 4x minus 4. Look at the slope, look at the y-intercept, look at the inequality to see if you should have a shaded or solid boundary line, a dashed or solid boundary line, and are you going to shade above and below. Question number 2, what is the inequality for the graph below? What's the slope? What's the y-intercept? Look at the boundary line, is it dashed or solid? And look at the shading area, is it above or below the boundary line?